Hi guys, so today we're continuing with quadratics, and this time we're going to talk about other key features of a quadratic function. Okay, so a quadratic function is a polynomial with a degree of 2. Okay, it can consist of a quadratic term, so x squared, a linear term, x to the power of 1, and a constant. Okay, so as we see here, these are different forms of a quadratic. And as we see, it's a degree of 2. Okay, this will be a degree of 2 as well. When we do x times x, it'll be x squared. Okay, and so that's why this is also considered. Okay. We have different forms. Okay, so the standard form of a quadratic function, we already seen, it looks like this. F of x equals ax squared plus bx plus c. Okay. We have the the vertex form of a quadratic function. It is called that because it gives us the vertices of it. Okay, and it looks like this. F of x equals a times x minus h squared plus k. Okay. And then the last one here is our intercept form. We're not really going to be focusing on intercept form here, but intercept form gives us our x-intercepts, and it's written in this form. F of x equals a times x minus p times x minus q, where p and q give us the intercept. Okay. So today we're going to talk about axis of symmetry, vertex, y-intercept. Okay, so axis of symmetry, it's the line that cuts the parabola into two equal halves. They're mirror images of each other. And to find that equation, we do x equals negative b over 2a. Okay. The vertex is where the parabola turns. It's either going to be a maximum or a minimum point. Okay? And what we do is the vertex is on our axis of symmetry. So we're going to use the x value that we found from the axis of symmetry. We're going to plug that in, solve for y, and that gives us the vertex. Okay? A y-intercept is where the graph crosses the y-axis. We can either plug in 0 to solve, or if it's in standard form, it's going to be 0, comma c. Okay. And then the x-intercept, also known as zeros, is where the graph crosses the x-axis. Okay, and we can either look at the graph to find that, but sometimes that's unclear. We will learn how to solve it specifically, even if it's not clear on the graph, when we do 7c, when we learn how to solve for quadratics. Okay. So let's get started. So here, we're going to start with x squared plus 4x plus 3. Okay, this is in standard form. It follows the pattern ax squared plus bx plus c. And we're going to find the axis of symmetry. So the first thing I'm going to do is list what a is, what b is, and what c is. So a here is 1, okay, because it is 1x squared. Okay. B here is 4, and c is 3. Okay. So to find the axis of symmetry, it will be negative b over 2a. Okay, so I'm going to plug in what I have. So b here is 4, so negative 4 over 2 times a is 1. Okay. So negative 4 over 2 times 1, which is negative 2. So my axis of symmetry is x equals negative 2. Right? And so what I'm going to do is I'm going to take this, and then I am going to graph it. Okay, so here, this is my axis of symmetry. Okay. Then I'm going to find the vertex. So what I'm going to do is I'm going to take this x value from the axis of symmetry, okay, because my vertex is going to be somewhere on this line, and I'm going to plug it in. Okay, so I'm going to plug in negative 2 for x here. So equals negative 2 squared plus 4 times negative 2 plus 3. Okay, plugging it in. Okay, negative 2 squared is negative 2 times 2, negative 2 times negative 2, so that gives me a positive 4. 4 times negative 2 is negative 8 plus 3. Okay, 4 minus 8 is negative 4 plus 3. This gives me negative 1. So my vertex is at negative 2 negative 1. So negative 2, negative 1, that is right here. I'm going to plot my point. Okay. Will the vertex be a maximum or a minimum? It's going to be a minimum, okay, because my A here is positive, which means that it is going to open up. Right? And if it opens up, that means I'll have a lowest point. Okay. Then it asked me to find the y-intercept. The y-intercept is going to be 0, c when it's in standard form. So since c is 3 here, the y-intercept is at 0, 3. I'm going to graph that. Okay. And then, since this is the axis of symmetry, it will mirror over. So this point is 1, 2 away. I just go 1, 2 more away, gets the other side. Okay. And then I'm going to also graph negative 1. I'm going to plug in negative 1, and I'm also going to plug in 1. Okay, so super easy. All you have to do is graph one side, and then all you have to do is reflect it or mirror it over to the other side. Okay, so here's negative 2. So I'm going to do negative 1 and 1 here. So x, y, right. We already have negative 2, right? Negative 2 comma negative 1. So I just need negative 1. So I'm going to plug that in. So negative 1 squared plus 4 times negative 1 plus 3. So all I did is take negative 1 and plugged it in for x. Negative 1 squared is 1. 4 times negative 1 is negative 4 plus 3. So 1 minus 4 plus 3 is 0. So negative 1 comma 0. Okay, I can mirror it over 1 away from the axis of symmetry. 1 more away gets me the other side. Okay, so I have negative 2, negative 1, 0, and then I'm just going to see if 1 also fits in. So I'm going to plug in 1 squared plus 4 times 1 plus 3. 1 squared is 1, 4 times 1 is 4 plus 3. That gives me 8, so that's going to be 1 comma 8. Okay. Then I'm going to mirror it over. This is 1, 2, 3 away, 1, 2, 3 away for the other side. Okay. I'm going to connect and connect. Okay. And then identify the domain and range. So domain, it's going to go to the left forever and to the right forever, right? So this is going to keep going to the left. This one's going to keep going to the right. So my domain here is negative infinity to infinity, also known as all real numbers. Okay. And then my range here, okay, so going from bottom to up. So here it hits it at negative 1. That is my lowest y value. It includes it, so bracket. And then all the way up where I hit an arrow going upwards, so that means it's going towards positive infinity. Okay. Another way to write it is that all my y values are greater than or equal to negative 1. Okay. This is interval notation. This is inequality notation. Okay. So then I'm going to flip. Okay, and let's try a couple more. Okay, so here we have f of x equals negative 2x squared plus 2x minus 1. Okay, I'm going to start by labeling what a, b, and c is. So a here is negative 2, b here is 2, and c here is negative 1. A goes with x squared, b goes with x to the power of 1, c is the constant. Okay. Axis of symmetry, x equals negative b over 2a. So I'm going to plug in 2 for b, so negative 2 over, plug in negative 2 for a, okay, and solve. Okay, 2 times negative 2 is negative 4. Negative 2 over negative 4 is 1/2. Okay, so here my axis of symmetry is x equals 1/2. Okay. So this one's a little harder, and as a result, I'm going to actually use a thinner pen. Okay, so x equals 1/2 is here. Okay, this, maybe I need a ruler even. This is my axis of symmetry. Okay, that's my axis of symmetry. Okay, to find the vertex, I'm going to plug it in. Okay, so I'm going to plug this in to find the y value for my vertex. So f of 1/2 equals negative 2 times 1/2 square plus 2 times 1/2 minus 1. Okay, 1/2 squared is 1/4, right? 1 squared is 1, 2 squared is 4. 2 times 1/2 is 1. Okay. Then negative 2 times 1/4 is negative 1/2 plus 1 minus 1. Okay, these cancel out, leaving me with just negative 1/2. So my vertex is at 1/2, comma, negative 1.5. Okay. So I'm going to plot that 1/2, negative 1/2. Okay, so it's right there. Okay, will the vertex be a max or a min? It will be a maximum or a max. And I know this because A here is negative. That means it's going to open downwards like this. It's going to be concave down or open downwards. Okay, that's how I know. Okay. My y-intercept is 0, comma c, and since c here is negative 1, my y-intercept is going to be 0, comma negative 1. So I'm going to plot that here, 0, comma negative 1. It is half away from my axis of symmetry, half more away, maybe the other one. Right. And then I'm going to, since I already have 0, or this 1/2 and 1, I'm going to do 2, 3 as well. Okay. So I'm going to do 2 and 3 as well. Okay. So plugging in 2 for x. So negative 2, 2 squared plus 2 times 2 minus 1. Okay, 2 squared is 4. Okay. Negative 2 times 4 is negative 8. 2 times 2 is 4 minus 1. Negative 8 plus 4 minus 1 gives me negative 5. So it's going to be 2, comma, negative 5. So 2, comma, negative 5. This is 1.5 away, so half, 1, okay, mirror it over. Okay. Then I'm going to do 3. Again, you only need to find it for one side because then you can just reflect it over. Okay. So now I'm going to plug in 3 in. So negative 2 times 3 squared plus 2 times 3 minus 1. Okay. 3 squared is 9. Okay. If it doesn't help you to write it like this, you can just write it like downwards like this. It's just because there's not enough room, so that's why I'm writing it horizontally instead of vertically. Okay. So negative 2 times 9 is negative 18. 2 times 3 is 6, so plus 6 minus 1. Okay. Negative 18 plus 6 is negative 12, minus 1 is negative 13. It doesn't fit in my graph, so I'm going to stop here. Okay, and then make sure you don't cross it because technically it should be down here at negative 13 for my next point. Okay, so since that's not on the graph, make sure you don't cross the line. And there you go. Okay, domain and range. Okay, so domain here, since it goes left and right forever, it's going to be negative infinity to infinity, right? This here is going to the left. This here is going to the right. Okay, nothing is stopping it, so that's why it's negative infinity to infinity. The range, so up and down here, I hit arrows, so that is negative infinity, right? If I hit arrows going downwards, that's negative infinity. Then it goes all the way up here and then stops here at the vertex, which is at negative 1/2. And since it touches it, it's going to be a bracket. Okay. We're going to try one more before we move on to something else. Okay, so last one here. F of x equals 3x squared plus 2. Okay, I'm going to start by finding a, b, and c. Okay, so here a is 3. Okay, because it's 3x squared. Here, do not be tricked. B is not 2. B is actually 0. Okay, why is that? It's because it's 3x squared plus 0x plus 2, right? So please remember b here goes with x to the power of 1. Since x to the power of 1 is not here, that means b had to be 0. That's why it's no longer there. Okay, and then c is 2. Okay, so axis of symmetry, x equals negative b over 2a. So b here is 0. A is 3. 0 divided by anything is 0, so my axis of symmetry is x equals 0. Okay. And then I'm going to plot it. Okay. There's x equals 0. To find my vertex, all I'm going to do is take this and plug it in. So f of 0 equals 3 times 0 squared plus 2. 0 squared is 0 times 0, which is still 0. 3 times 0 is 0. 0 plus 2 is 2. So my vertex is at 0, 2. Okay, so it's right here. Okay. Will it be a max or a min? It will be a minimum. Okay. The reason why is because A here is positive. It's a positive 3, which means that the graph will open upwards. It's concave up. So that's why there ends up being a minimum. Okay, y-intercept here is 0, c. And so since c is 2, it's 0, 2. And as we see here, our y-intercept this time is actually our vertex as well. All right. And then after that, I'm going to plug in some points. So again, you only need to do one side because you can just reflect it over. Okay, so since here is 0, I'm going to do 1 and 2. Okay, let's see if it fits. If it fits, then maybe I'm going to do 3 as well. Okay, so I'm going to do 1 first and 2. Okay, so I'm going to plug it in. Okay, so plugging in 1, 3 times 1 squared plus 2. 1 squared is 1, so 3 times 1 plus 2. 3 times 1 is 3. 3 plus 2 is 5. Okay. Then I'm going to plug in 2. Okay. So plug in 2 into my equation. Okay. 2 squared is 4, so 3 times 4 plus 2. 3 times 4 is 12. 12 plus 2 is 14. And since that doesn't fit, I'm going to stop here. Okay, so I'm just going to graph 1, 5. And then I'm going to mirror it over. Okay, so 1 away, 1 more away. Then I'm going to graph it. And there you go. Okay. And then domain, since it goes to the left, right, it's moving to the left, and here it's moving to the right forever, domain is negative infinity to infinity, or all real numbers. Range, okay, so from bottom up, so bottom hits here at 2, includes it, so y value here is 2, included, so bracket. It goes up, 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 hits arrows going upwards, so it means that it's going to head towards infinity. Okay. Then, let's flip it over, okay. And so now, we're going to consider the graph shown. We're going to find the axis of symmetry. Okay. So here, if we look, okay, this is where the vertex is. It's about halfway. This one's not very good because you can't see it very clearly, but it's about halfway. So the axis of symmetry will be x equals because of vertical line, and here it's at -1/2, so x equals -1/2. Vertex here is like 3.5, right? So x value is -0.5. Y value 1, 2, 3, -3.5. So -3.5. This is a minimum. It's the lowest point. It's the bottom of a valley. So minimum. Okay. Y-intercept, where does it touch the y-axis? That's right here at 0, -3. So y-intercept is 0, -3. And then x-intercept, since we can see it nice and clear, this one is 1, 0. This one is -2, 0. Right. Quadratic functions, they're supposed to have arrows here. The domain is all real numbers because it goes to the left forever and to the right forever. And the range up and down here hits here at -3.5, includes it, so -3.5, and then goes up towards infinity. And one more here. So axis of symmetry, so where the vertex is, that's right here. So axis of symmetry is x equals -2. The vertex, this point here, is -2, 1. Here we see that it is a minimum again, because it is the bottom of a valley. Y-intercept, here's the y-axis, so here's where the y-intercept would be, 0, 2. X-intercept, here's the x-axis. It does not touch it at all. It will never touch it, so there is no x-intercept. Domain here, again, is all real numbers. The reason why is here, it's going to go to the left, and here it's going to go to the right forever. And then range is up and down, so here, going from the bottom up, here it hits at 1, and then goes up forever. So that's it for today. Have a great rest of the day. Bye, guys.